Welcome to the final true or false challenge. Here's the first question. True or false? P-type and N-type materials are both conductors. The depletion region, which lies between the p-n junction, is much like a dielectric or insulator. Therefore, a diode has some natural capacitance. Is this statement true or false? So to be able to answer this question, you have to understand what capacitance is and how capacitance is formed. In this case, the answer is true. Does this sound like something that we've learned in the previous true-false? It does. It should sound a lot like parasitics. Because we don't intend for there to be some natural capacitance, it just occurs because of the natural behavior of the device. True or false? Resistance is inversely proportional to the mobility of carriers. That statement is true. It basically says the more free the carriers are to move around, the less resistance there is. That should make sense. Now, the next statement is true as well. Holes have a somewhat orderly movement, meaning hole movement is defined as electrons jumping from one space to the next. Now, this is what you have to determine whether it's true or false. It says, therefore, p-type material has less resistance than m-type material. In other words, this question is asking, are electrons faster than holes? True or false? The answer is false. Holes are slower than electrons. And the reason that is true is for the reason stated in the problem. They have very orderly movement, whereas electrons can move freely as they please. True or false? This CMOS topology is effectively a digital NOT gate. The answer is true. The output will be high only when the input is low, or vice versa. True or false? All semiconductor devices are active components. True or false? All semiconductor devices are active components. Again, we define active components as components that need input power to function properly. So, is this true for all semiconductor devices? True or false? The answer is false. Although it's true from the most common semiconductors, such as diodes, transistors, solar cells, LEDs, etc., but we can make passive components with semiconductors as well. True or false? A reverse bias diode is essentially an open switch. So again, this illustration is a diode that is biased in the wrong direction, so you have a very wide depletion region. True or false? The answer is true. And the reason is because no current will flow. The next question says, the energy band gap is formed when atoms become closely packed together, or in other words, lattice spacing decreases. Is this true? It is. And the reason is because of quantum physics principles that are pretty difficult to explain. True or false? P-type dopants are also called acceptor concentrations. True or false? The answer is true. And N-type concentrations are called donor concentrations. True or false? Indirect bandgap semiconductors are fundamentally useless in optoelectronic applications. True or false? We already talked about direct bandgap semiconductors and why they're used for LEDs and solar cells, because it helps the electron hole recombination process to be much more efficient, so that the energy released through that process will create a photon and generate light. But is this statement false or true? The answer is false. Even though most optoelectronics are used with direct bandgap semiconductors, indirect bandgap semiconductors can still be used. They're just far less efficient because you lose more energy in the distance the hole has to travel to recombine with the electron. True or false? The built-in voltage of a p-n junction is solely contributed by the potential difference of the positive and negative ions of the depletion region. So again, we stated after the diffusion current in a p-n junction, after the fusion process, a depletion region is formed here. And that is essentially the voltage drop across it. That's the voltage you have to overcome in order for current to flow through this device. But is that solely contributed by the potential difference of the positive and negative ions? True or false? It's true. That's actually the definition of the built-in potential. True or false? Mobile carriers in the conduction band are the only ones that are included in the current flow. So again, in this, we talked about two different bands, the conduction band and valence band. As question is, are the mobile carriers in the conduction band the only ones that are included in current flow? True or false? The answer is true. If the carriers are conducting, that means that they are producing current, thus we get the answer true. True or false? A square wave voltage input is primarily an analog signal. True or false? The answer? False. Now this is actually a tricky question, and has been the point of heated debate among engineers. Because when you look at a square wave, obviously it has the two states, and it's most commonly used for digital clocking, but these transitions are not perfect. There's no way to generate these perfectly transitioning square waves with the technology that we have now. So we would consider those transitions to actually be analog. However, given the high-low states and given the application of this square wave, we would still consider this primarily to be a digital signal. True or false? Given how MOSFETs function, they must have a significant amount of parasitic capacitance. So we're thinking about this on a device level. We're thinking about this from how it's laid out using semiconductor materials. Is this statement true? It is. The answer is true. If we think about how this is made, it has a electrode here. If it's an NMOS, that's P, that's N, that's N. So again, this part forms a capacitor because this is a dielectric and then electrode. This is an NP junction, so that forms a capacitance. That forms another capacitance. So in this case, there is isolating material at the gate as well as several PN junctions that will diffuse and create depletion regions that form these forms of parasitic capacitance. And if you ever become a circuit designer, you'll have to deal a lot with parasitic capacitance. True or false? When a BJT device is used as a switch, the collector current will equal the emitter current. True or false? The answer is false. And we already stated this in the previous example. There's always some current that's lost at the base of this. And that's why the BJT doesn't make a perfect switch. So as you can see, if we say that this is a node, there's two currents coming in and one coming out. So we can say IC is equal to IE minus IB. Now for the final question, true or false? If we wanted to, meaning it's possible to, we could use mechanical switches and integrated circuits the same way MOSFETs are used today. True or false? The answer is true. There's actually some research being done on using micro mechanical switches to be able to implement this exact thing. But the reason we don't use them today is because mechanical switches are less reliable. They can get stuck, they can break, and everything like that. So thanks for taking this true-false challenge. I hope you did well. Have a great day.